Right, so before we look at the loading calculation, I will just do a quick revision. So I call it revision because you have seen this thing before, or you have learned this thing before in your other courses contact in your first year or yeah. So what we're going to do is to look at some basic thing about one-way slab. Definitely you have learned this before. One-way slab, two-way slab. And usually on a construction drawing to indicate a one-way slab, you use the symbol like this or like that, which actually indicates the direction of loading. Right, this is actually the direction of, not the direction of the direction of load transfer. Load transfer. For a two-way slab, it's a bit different. Like the cross. That indicates the direction of load transfer for a two-way slab. So I'm just going to go through just something you learned before. I sketch a rectangular slab. So usually you draw the plane of a slab. So for a rectangular slab, so dimension, let's draw the beam first. So this slab is supposed to be supported by beams around the edges. So these dotted lines indicates the beams underneath the slab or supporting the slab. Right, so if you want to cut the section, so if you, let's say you cut a section here, say this is your section AA, or if you want to cut a section BB, more or less the same. So if you cut a section AA, that would look something like right, so that's the beam supporting the slab like that. Right, so this is your section AA. Right, and then I define the length or the span of the slab. So to define this span, you don't measure from the edge to edge. You measure from the center line of the support. So along section AA, those two are the supports, those two beams. So on the cross section, this is the center line of the left beam, and that's the center line of the right beam. So the distance between those two center lines, that it's defined as the span, right? A. So let's say this is little a. So same thing, you can draw section BB, which is exactly the same, except that it's a bit shorter. So this is your little a, right? And along the other side, it's your little b. So the thing is, how do we define a one-way slab? So that's defined on the ratio between A and B. So if A is greater than or equal to 2 times or twice B, then it's one-way slab. That means the longer side is at least twice the length of the shorter side. Then it's a one-way slab. Of course, otherwise it's a two-way, right? So otherwise it's a two-way. And then the most important thing is, of course, once it's a one-way, then you need to look at the symbol, the direction of the load transfer. So for this case, let's assume that A is greater than twice B, or double B. Then the direction of load transfer is along. It's always along the shorter direction. Right? This B is the shorter direction. So the direction of load transfer, this symbol is always along the direction of the shorter span. So I just mark it down here. This is along the shorter span. So in other words, if B is larger than A, then that symbol would be in the horizontal direction, right? So if you have a situation like that, if this is your A, which is now much shorter than B, if that is the case, then that symbol would be like that. So it's always along the shorter span. Right, so definitely you have heard of this two-way and one-way slab before. And so that implies if this is a one-way slab and the load transfer is in this direction, so that means the loading on this slab, including its self-weight, is transferred to this beam. And this beam. Right, so this is what this symbol actually means. Right, so all the loading on the slab, including its own weight, it's transferred to these two beams. And then this beam is probably supported, let's say, by a column at the corner, let's say, like that. By another beam, by another column, this corner. And for the beam here, it's supported by another column at this bottom left corner, at this bottom right corner. So the loading on the slab is first of all transferred to the beams on these two sides, and then because the beam is supported by these two columns, we say the load is then transferred to those two columns. So I can write down that my loading on the slab is first of all transferred to the slab, and then according to the direction of the load transfer, it goes to the beams. And then because the beam is supported by those two columns, it goes to the column. So this is what we mean by the low path. Right, so the loading, all the loading on the slab, including its self-weight, will be transferred to the beams according to this direction. And then because the beam is supported by columns, the load is then transferred to the columns. And of course, you can continue this load path. The columns will be supported by pile caps, let's say, or rock footing. Then it will be supported by caps. Or you can say the loading is transferred to the cap and then transferred to the piles underneath. And then down to the bedrock. So that's the complete load path. Right, so something about one-way slab. And then we'll try to do some very simple calculation here. So we're going to do some loading. So let's start with the live load. So live load. So where can you find the live load acting on a slab? You can find it from the regulation or the code from the building department website. So you can find it from the BD website. Right, so there's a code which is freely available on the BD website for all buildings in Hong Kong, depending on the function. They specify all the loadings, all the necessary loadings you need. So, for example, if you're going to design a whatever car park, then if you look at the BD code, that would be 5 kPa. So that definitely is a uniformly distributed load on the slab. That specify a UDL on the slab. So it's a UDL, uniformly distributed load, or that's equivalent to kilonewton per meter square. So for each meter square on the slab, there is 5 kilonewton of load everywhere on the slab. That's the meaning. And this is how you specify the loading on a slab. And usually on a slab there will be also some finishes, right? There will be some finishes. So there will be finishes loading. And depending on what finishes you use. So the finishing loading can change a lot. It really depends on what type of finishes on your floor slab. Okay. 視乎你用啲乜嘢嘅鋪咗啲咩上落地面嘅。如果你鋪咗雲石上去，咁當然係好重。So let's say if you're going to put a marble floor, so some finishes. So let's say if you're going to apply some finishes with density, whatever, 20 kilonewton per meter cube, some heavy thing you could apply as finishes. And then you also need to specify the thickness. How thick is your finishes on the slab? So let's say it's 20 0.02 meter. Right, so if you multiply your kilonewton per meter cubed density with the thickness, right, that is the thickness. THK stands for thickness. So if you multiply these two together, what do you get? That is 0.4 kilonewton per meter cubed times meter. Of course, that will give you kPa. And that, of course, is again a UDL, right? So most loading on a slab are specified in terms of a UDL, something kPa, something kPa. And then finally, the wells, what are the vertical load on the slab? Live load finishes and probably self-weight. So how to calculate the self-weight? Let's say that it's a RC slab. So the density of concrete, we mentioned it last week, that's 25 kilonewton per meter cube. So for self-weight, it's 25 kilonewton per meter cube. That's the density of concrete. And then you try to also, like live load, like finishes, you always express your loading on a slab in the unit of kPa. So that is kilonewton per meter cube. Again, you need to multiply by the thickness. How thick is the slab? So let's say this is 150 millimeters, so that would be times 0.15 meter thick. So 25 times what? 0.15, that would give you 3.75 kPa, kilonewton per meter square. So make sure you're familiar with all these units. So in all these calculations, the units are actually quite important because the units are wrong, then everything's just wrong. So at least you should now have an idea of the loading on a slab, something about the magnitude. Right, finishes usually on a construction or building construction, 0.4 is usually a bit on the low side. So usually in practice, the finishing loading is it's usually about at least half a kilonewton per meter square or 1 kilonewton per meter square. But it really depends. Sometimes it goes to 2 or 3 kilonewton per meter square. It really depends on what finishes you use for the floor. So sometimes it could be quite heavy. But it won't be as much as the live load or the self-weight of your slab. Unless you put a planter, then you need a layer of soil plus water, then it will be very heavy. And if you make mistake in your loading, that would be something that I try to explain. So let's see. Let's see what happened to your CTU green roof. No more. that it's